Stan Gibilisco here, showing you the Amazon page for my book Electricity Demystified, 2nd edition. I will provide a link to this page in the description of this video so you can go to the page, look inside the book if you're so predisposed, and decide whether you want to buy a new copy or buy a used copy or find some other way to get a copy. Here's the table of contents, and we're going to look at the last section in Chapter 12, Magnetic Levitation, and in particular, Maglev trains. That's what I'd like to show you now. There are two designs. This is figure 12-15A from Electricity Demystified 2nd edition. Two designs in order that magnetic levitation can be employed to move a train along a track in an almost frictionless manner. Here's the first method. Now let's just imagine that the train car is either moving straight at us or straight away from us. So we're looking right down the track, and this is a cross-sectional view. There are two bearings, one attached to the car, and then the other, it's not really a bearing, it's the track itself. And they're both magnetized, and of course they're magnetized in such a way that there is a repulsion or a repulsive force between this upper bearing and the track. If that force is just right, then the train car will hover above the track, and the magnet, of course, is the same polarity, all facing out from the track and all facing in from the train. Usually the track is powered by electromagnets, and so is the train, because you can't very well make permanent magnets strong enough to accomplish this levitation. And in this little gap right here is nothing but air. And that's the only thing besides the air resistance against the train cars themselves as they move that offers any friction. So this train will, if you shut off the magnets, coast downhill or uphill if the terrain is not level. But of course you can regulate the speed of the train by regulating the pulses that travel along these magnets in the track to make the train move from one part of the track to another part. It's a quite complicated business, and this book doesn't get into much detail about it. It only shows the very basic principle. This is one method of doing that, of accomplishing magnetic levitation to support a train car above a magnetic track. The other method is just exactly the opposite. The track surrounds the train car bearing or set of magnets like this, so they work just the opposite way. You can see the difference just by comparing figures 12-15A and B. There is some text that goes along and describes how this works and what happens if the magnets fail. Suppose there's an electric power failure. What's going to happen? Well, unless there's some sort of way to protect the train and the track, this train car is going to land on that track, and there's going to be, besides a horrible screeching noise, probably a very unpleasant ride for the passengers in either case. But there are ways that problem can be protected against, and the text in the book describes those methods. The text in Electricity Demystified, 2nd edition, written by yours truly, and you can go and buy it, or you can take it out of the library. You can, if you're interested, get a copy somehow, but it's best if you do it in such a way as to get a bound copy. There are several reasons for that. A paper copy. Electronic copies tend to have formatting glitches that can show up in different book readers, electronic book readers, in different ways that can sometimes be very disturbing indeed. I won't go into that because I've talked about it in other videos. But the bound book is really cool because you don't have to boot it up. If the power fails, it will not fall on the floor and make a terrible screeching noise and give you an unpleasant ride. So that's the way that works. I don't know how things work in this galaxy, though, except in the black hole at the center of this galaxy. Things obviously work a whole lot different than anything we've ever imagined, including Maglev trains. Again, I will provide a link to my book, Electricity Demystified, 2nd edition, in the description of this video, so you can go to the Amazon page and decide whether you want to buy it or not. Stan Gibilisco signing off for now. Until next time, so long.